Okay, so in this video, we're going to run through the implementation of this Python code for Cox Ross Rubinstein, which has been optimized in a style consistent with Espen Haug 2007. Now, I've done a video previously here, and we just implemented this Python code in the online GBD compiler. This time we're going to set it up in Spyder, and to do that we have to launch the Anaconda navigator. Now, just to explain, if you don't have Anaconda navigator installed on your machine, you can follow the steps here in the installation guide just on the home page. Right, and that'll takes a couple of minutes to do that and to set up each of the packages. But we're going to copy, so we come down here to binomial framework, and then under Cox Ross Rubinstein come into the optimized code. So let's just take this snippet of code that was originally developed by Tinya's. I'll mention the link here. We just copied this code, right? And okay, copy. And we go into Anaconda, right? So let's just share screen for Anaconda. Share, and then we launch Spyder. So I'm going to launch the Spyder compiler, and that just takes a second or two. And we can take out this code here. So this was a previous snippet of code. We can remove that, paste. Okay, and let's just implement. Now we could format a bit better, but not that important here. And you can see we've printed out here the value of the European call, American call, European put, American put, and that's consistent with Espen's estimation. We can look at the variable explorer, and we can look at these values here as well. If we change from P here to A, we will get delta and gamma as well. So A here denotes not American in this instance, actually it's all. And the output then will include an array for delta and gamma and the price. Okay, so let's run that again. And this time we expand our screen. This time you can see we get output for the price of the option. So the European call is 1043, American call 1043, European put 555, American put 608. The parameter values were S equal to 100, X equal to 100, T equal to 1, R equal to 5%, cost of carry, that would be R, negative dividend yield was 0.05, implying no dividend yield. Volatility or standard deviation of the stock return, 20%, and we had 10 steps in this tree. We noticed that the delta here and the gamma are reported to the same for both the American call and European call, because it wasn't optimal to exercise the American call early, given that the dividend was 0. In the case of the European and American puts, there is a difference in price. That is because in this instance, it is optimal to exercise the American put early, so it's worth more, and we can see the value of delta and gamma respectively.